want to know if the express lane is faster on average. Okay, so if the express lane is faster, it should be the case that if I subtract the time from the normal lane from the time in the express lane, I should get positive number values, right? That seems to make sense. All right, cool. So let's go ahead and subtract. So we can get our data that we have in our calculator. And we can call this one lane diff. I'm not using just diff because I have a feeling that it's already a function in the calculator, and if I put diff in there, it's going to be like, no, what are you trying to tell me what to do? So, what are we going to do? We want this to be express minus reg. Is diff a function? I'm not sure if it is, but I was gonna avoid using it because it freaks out if you put a function up there. All right. Yeah, so we should get a series of. I feel like we need to go the other way. Because that's like positive number values, right?
Yeah, you're right.
Yeah, that's not good. Sorry. We want reg minus express.
Maybe. I cannot see. Oh, I know.
There we go. Okay. So, if the express lane is not any faster than the regular lane, right? Then the difference should be 0. Right? So let's go ahead and go through this. Now that we've got our data, let's start the problem. So our parameter of interest is sorry, not mean time, but mean difference, right? Okay. Our hypotheses. Our null hypothesis should be that u is 0, right? If it's greater than 0, then indeed it is faster. Right? Okay. Let's go ahead and carry out a test so that we can get all of our data that we need in order to do our assumptions and all that stuff, right? So, carry out the test. So I'm going to have to do doc. I'm going to have to insert. First, I guess, I don't know, I'm so curious. I can't help it. I want to carry out the tests. I got to know. Yeah, but so I will put in a data and statistics page, but I mean, I don't know why. I like to, as a kid, I would actually read the last chapter of the book and then read the rest of it because it was satisfying to know what was going to happen. Do you do that? I just couldn't. I don't like the suspense. I like knowing. I don't know. It's really weird. I've done it a few times. I didn't do it a lot, but just kind of want to know where it's going. You know what I mean? Is it even worth a read? All right. Let's do a stat test. We're going to still do a t-test. Did I?
Did you?
I got the t-test. Cool. Thank you, though. Thanks for looking up. We are going to use data. Yes, sorry. And my list is lane diff. And we want that mu is greater than mu naught. Hey, you got a nice little p-value. Cool. So we'll refer to this when we get to the after assumptions part, right? So now we can go through and I just like to look at it and see what's going on. Obviously, egg's not big enough, right? Anything else that we need to think about before we move on? Not really. All right. Let's go ahead and insert the data and statistics page. And the reason why we're doing this is just so that we can check our assumptions. I don't know if that's an outlier or not. There's a very cool trick to find out if it's an outlier. If I make a box plot, it'll actually tell me if it's an outlier. It actually does the calculation for me. So let's go ahead and change this to a dox plot. It is not an outlier. Right? If it was an outlier, there would be a gap and then it makes it a little star. Right? That particular point. Not an outlier. It's good enough for us to just say it's not. We're not going to have to show the calculation. That data looks pretty good. I'm going to go ahead and use that box plot to justify that as well. Okay. Let's go ahead and get to A. The data comes from SRS. I think that 150 is, huh? Right, it's reasonable. to assume that there are more than 150 transactions or customers through a lane or whatever you want, right? Now I'm going to go ahead and copy my box plot. 0, 100. What in the world did I just do? Oh, that's why. It went up to, my bad. That should be going up to 250. That's my problem. 100, 150, 200, 250. And obviously this is much easier to do when you have the box plot in front of you, right? I'm having to real quick memorize what's what. All right, so the graph shows no obvious skewness or outliers. So we'll go ahead and continue with 18 tests. T, we'll get our test statistic. Which we can grab from here. All right, so X bar, so 42.667. T equals 42.667 minus 0. What is the standard deviation? Anybody got that for me? 84.019 divided by the square root of 15. Which turned out to be approximately 1.967. Yay, let's obtain a p-value. So p, we want the probability that z, t, is greater than 1.967. We're going to draw a picture of that. Okay. And then what was our p-value? 0.03. What? Huh? 647?
0.03467.
Cool.
Is that 8?
68. We will round, and then that means that we need to say it's approximate. Okay. Cool. Awesome. Let's make a decision. We will reject a null hypothesis. Keep writing that up. We will reject it's not.
Would this kind of be like subjective because you cannot like you can manipulate the data to make it to where it's always positive if you like subtract a certain correct number, so you're how does it be applicable because you can manipulate the data to where you're subtracting two data pairs that are different enough to have all these songs be positive or all these songs be negative.
You're saying by rearranging the data, by choosing which ones you're going to subtract from, but overall, what the overall difference is going to.
Not always, because you can make it where like you have two data points that are in the positive and negative.
Oh, and just choose those two?
Yeah.
Yeah, so.
Is that why you would?
That's the thing. So, statistics can be used very unethically, right? You can totally do correct statistics with data that's been manipulated in order to create a result that is favorable. And I'm sure it happens all the time. In fact, the most convenient way to do that is to enter some bias into your data collection. That makes it look like you haven't, because you don't want to manipulate the data. That looks very bad, right? But if you collected the data in such a way that you know that your outcomes will give you a nice p-value, then while you've done something unethical, you didn't really tamper with the numbers. You know what I mean? There's a quote that I forget who said it, but he said there are lies, damn lies, and statistics. You can do a lot of lies. You're right. Yeah, I actually got that from an older stat teacher. We did one of the AP stat conferences in his room, and he had that written there. And he was a crushing it. Huh? So at the alpha equals 0.05 level. All right. So we can say there is significant evidence. So that's our S, right? So evidence that the express rate is faster.
And there's no significance using the using the two samples.
Oh, it wasn't significant? Okay. interesting. And we'll talk about the difference. So when you're using it, and that's coming right up. It's a good segue into the next thing. We're not comparing means, right? Because, yeah. So when we're comparing means, then we're going to do that. So this is a different problem. We really want to know about the difference between the two things. So that's why it comes out to be weird. Okay, fantastic. That's done. Guys, little note, all right? If you miss any of the letters from phantoms, it's automatically a P. Alright? And you lose a point, like right off the bat, right? And that's the way an AP grader is going to do it. The reason why we have all these here is because each one of these components is essential. If you miss one of these components, it is not correct. So just a heads up, okay? Go through the process. It works. I've talked to the person who gave me this format, and she said that she has spoken to students who actually wrote the P, the H, the A, all that on their AP exam, and they were not marked off for it. So if you need to, go ahead, right? It's okay. All right. Really, all that's left are some conversations. Really, honestly, we're not being even asked any questions with these. We're just talking about it. All right, just a little discussion. So the superintendent wants to buy a large computer-based math program for his district because the program is very expensive. He will randomly select some classes to pilot the program. The response variable will be the average increase in grade level equivalent for students in the class. For example, if a student went from 3.1 to 4.3, the student increased. Okay, cool. So we're looking at a difference again. So we want them to increase one grade level. All right. Huh? A what grade?
Because it's like third grade 1 month. There's no 12 months. There's 12 months in a year.
Yeah, that's not very well done, is it? That's base 10. It doesn't make any sense. You know what? All right. So the superintendent wants to avoid a type 1 error. So he chooses a very, 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 very low alpha level. Okay. And then we look at the power of the test. And that's really it's just having a discussion about this principles thing, this particular example. And the corresponding example in your book, Developing Stronger Bones, is doing the exact same thing. Just telling you, just giving you an example. Really strange, but that's what's going on. All right. Another discussion though. So again, this example is just a discussion. So they just run through the thing, come up with a standard deviation, test statistic, and p-value. If you want to have a closer look at it, you may. I figured I'd put it on there since it was a resource, but it's just a discussion. We do get something quite interesting, almost there. again, another discussion point. Oh, here we go. This is good. So this is interesting. Actually, solving for an alpha level. So figuring out the probability of getting a type 1, of avoiding a type 1. So you can figure out the alpha level in order to avoid a type 1 error by solving this particular equation. Really interesting. Yeah, so I am 99% positive you'll never be asked to do anything like this. It's a very weird equation. Yeah. Figuring out how to solve. I mean, it's not terrible, but and it makes sense if you think about it, right? If you look at it, you're finding one significant result in 20. And so you're looking at, yeah, so that's where so you 1 minus your alpha level is going to be the probability of getting a type 1 error, right? And so you just want to find out how many times in 20 you could repeat that, or what your alpha level will be if you repeat that process 20 times. Anyhow, the next one is the same thing. And there are corresponding, oh no, that was it, sorry. I thought there were 2 of them. And there are corresponding examples like this in your book where you're not being asked to do anything, just showing you the idea of the power of your significant level. And that was it. We did it.